Any questions on the homework before we get started? Bless you. So what we're doing today is going to be new. Out of everything we've done so far, we really haven't covered any real new material, but today is going to be something new. Because we've been talking about A plus BI in these forms, but we can also write it in polar form. Because the way that we've been looking at complex numbers, or really points on a plane, is something we call rectangular form. And it makes a whole lot of sense. Because if we think of a grid, or not a grid, but a Cartesian coordinate plane, it's all on rectangles. Because if we look at, say, here, the point 2, 4, we go over 2 and up 4. Everything is a grid. It's all rectangles. It's all squares. So it's considered rectangular coordinates. Polar coordinates are going to be dealing with a radius and an angle. A radius and an angle. So we're going to be dealing with sine and cosine. Now to get there, we have our two parts A and B, and it's going to be dealing with r sine and r cosine. We can also say that this is r times cosine of theta plus I sine of theta. Now our r value is going to be the square root of a squared plus b squared. Our r value is going to equal the square root of a squared plus b squared. Where a is our sine, a is our cosine, and b is our sine. This is where we get r, and tangent of theta is equal to b over a. Well, that's nice and all. And we kind of write this out to the side to see this. Tangent of theta is equal to b over a. But to undo that, we'll take tangent inverse of both sides, which is really just telling us theta is equal to tangent inverse of b over a. So we want to find this. Really, we need to find the value of r, value of theta, and we can plug it in to our set formula. Now, it does make sense. A is our cosine and B is our sine. Because when we talk about cosine, cosine is adjacent over the hypotenuse. Adjacent side, when we think of our coordinates, adjacent would be our x-axis. Opposite would be our y-axis, so it kind of works out. Any questions on this so far? Now, tangent inverse is between negative pi over 2 and pi over 2. We're stuck between those two axes. So really, when we start trying to figure out what the angle is and how to calculate it, one of the biggest things I'd focus on is where this point would be on the coordinate plane. Is it going to be in the first, second, third, or fourth spot? And we can use that to get what the angle is. Because when we use tangent inverse of b over a, it's going to give us an angle either in the second, or in the fourth, or the first. It's going to be one of those two. And we can go from there to the other actual quadrant it's supposed to be in. So the first thing we're going to do is rewrite this in trigonometric form, or in polar form, for this here. So we're going to rewrite it into r times cosine of theta plus I sine of theta. We're going to get it in this form. But to get it there, we need two things. We need the value of r, and we need the value of theta. And r is equal to the square root of a squared plus b squared. Well, a in our case is negative 2. So negative 2 squared. Plus, b in our case is negative 2 square root of 3. Now we don't need the I because the I is not part of A and B, but we do have this here. Now at this point here, we could plug this all into the calculator and let it do it for us. And between the two calculators, I would pick the 30xs over the graphing calculator because it will leave it in radical form, unlike the graphing calculator, which is going to put it in decimal form. So we have -2 squared plus -2 square root of 3 squared. Gives us 4. So the value of r in this case is 4. Okay. So we can come over here and replace r with 4. Now we need to find theta. Unless it specifically states in the problem which one it wants, we can take either. We can take degrees or radians. It doesn't matter. But our angle theta is equal to tangent inverse of b over a. Well, b in our case is -2 square root of 3. And a is -2. We are able to simplify that if we want, or we can leave it as it is. Either way, we'll get the same answer. So we can say second tangent inverse of -2 second square root 3 over -2. Because I could have simplified it and just said tangent inverse of the square root of 3. Because -2 over -2 is 1. Enter. And it'd still give me the same answer. So 60 degrees. Now if we had it in radians, it won't tell us that it's 60 degrees. It'll tell us that it's this decimal or pi over 3. But pi over 3 and 60 degrees are the same number, same angle. Not same number, but same angle. So here we can say theta is 60 degrees. And that's our answer. Or we can say it's 4 cosine of pi over 3 plus I sine of questions on this here? Now we could have multiplied it through and said 4 cosine of 60 plus 4i sine of 60, just multiplied the 4 through, but it's not really changing the answer. Same answer, just a different way to write it. Questions on this here? All right, let's look at another one. We're going to write the complex number 3 plus 4i in trig form or in polar form. R is equal to a squared plus b squared. So in our case, it would be 3 squared plus 4 squared. Pythagorean triple. 3 squared is 9, 4 squared is 16, 9 and 16 is 25. Square root of 25 is 5. theta is equal to tangent inverse of b over a, so 4 over 3. And we can grab the calculator, say second tangent inverse, 4 over 3. We get this here, which is this. Switch it back to degrees. Let's get the same thing. And we get about 53 degrees. Or we can say 53.13. So it would be 5 times cosine of 53.13 plus I sine of and that's it. Now for most angles, as we've already seen throughout most of the semester, there's only a select few that we can get that work out to be a nice number. Others are decimals. Questions on this here? Are you ready for the next part? Write the complex number in standard form. So now we're going from trig to rectangular. Really, we can say we're going from polar to rectangular. And this one here, I found challenging when I was first learned this in calculus, because when we cover this in calculus, I found this really complicated, really hard to try to figure out. And I don't know why. Still don't know why I found it hard, because this is actually very, very easy. We have these two things here, yes? Cosine of 120, sine of 120. We can use the unit circle, or I can grab a calculator. Say sine of 120 degrees. So is square root 3 over 2. Cosine 120 is negative 1/2. Okay? So cosine of 120 is negative 1/2. And square root 3 over 2. So if I just plug those in the calculator, that's what I get. Yes? But we also need to multiply it by 4. 4 times negative 1/2 is negative 2. 4 times square root 3 over 2 is going to be plus 2 square root of 3. Hi. Yes? And that's it. Now you can see why I'm confused now, why I thought it was hard to begin with. Or really what I could have done is said 4, well, I couldn't do it in this one. We could have said 4 cosine of 120 degrees, 4 sine of 120 degrees. There's our two answers. Put them together. Questions on this here? Yeah, no, it wasn't until I taught this for the first time that I realized it's just plugging it in and you get your answer. That's it. We got it back into rectangular. Nope. So here, 2 cosine of 150 degrees plus I sine of 150 degrees. So we can say 2 cosine of 150 degrees. It's going to be negative square root of 3. 2 sine of 150 degrees is 1. And when I did it with the 2, really we were looking at 2 cosine of 150 degrees plus 2I sine of 150 degrees. And as we saw for this here, 2 cosine was negative square root of 3. Plus, we'll have I and sine was positive 1, so it's just going to be plus I. That's the answer. Questions on this here? We're ready for the next part. We'll do one of these here because it's good to see it in both forms because we can have it in both polar and rectangular. Not polar and rectangular. Radians and degrees. But it doesn't change anything. The only thing that we have to do here is change the calculator from radians to degrees, or degrees to radians. And 2 pi over 3 and 8. So we can say 8 cosine of 2 pi over 3 is negative 4. And we can say 8 sine of 2 pi over 3 is 4 square root of 3. So we have negative 4 plus 4, 4 square root of 3 I. And that's it. Questions on any of this here? This one? Same thing. Not any different. Because we don't have to have an R value that's a whole number. Because we can plug it in. Square root of 8. Because really that should be rewritten, or could be rewritten as 2 square root of 2. Second square root 8. Cosine of, I think it was negative pi over 3. Square root of 2. So square root of 2 minus I square root of 6. Or square root of 2 minus the square root of 6. I is this here. Questions on this here? Now, multiplying two polar numbers or dividing two polar numbers is actually easier than multiplying or dividing two complex numbers. Because when I multiply two polar numbers, or two trig numbers together, we multiply their R values and then add their angles. When we divide two polar numbers, we divide their R values and then subtract their angles. So if we wanted to multiply these two together, Z1, Z2, well, we're going to multiply the two R values together. So our two R values are 2 and 8. So we're going to multiply those together. Bless you. Inside, we're going to add the two angles. So we'd have 120 plus 330 plus I sine of 120 well, 2 times 8 is 16. 120 plus 330 is 450. That's it. This is a lot easier and multiplying the two complex numbers. Questions on this here? Now we'll divide two. Divide two complex numbers. And when we divide two complex numbers, so z1 over z2, well, we divide the r values. So 24 is on top, 8 is on bottom. The r value for the polar number on top goes on top. The one on bottom goes on bottom. Inside, cosine. The angle for the one on top goes first. So here we'd have pi over 3 minus the angle on bottom, 5 pi over 12. I sine. Same thing. I'd rewrite it, but I ran out of room. Now for this here, 24 over 8 is nice because it works out to be the whole number 3. Now trying to do 5 pi over 3 minus 5 pi over 12, I'm just going to grab a calculator. 5 pi over 3 minus 5 pi over 12. You're good? 5 pi over 4. And that's it. We feel pretty comfortable with product and quotient. Yeah. I didn't add a whole bunch in there because I didn't think we would need a whole lot of these here. That's it.